Okay, let's look at this problem here, guys. What's the answer to this? Do you remember from way back when? What's the answer to the limit of 1 over x as x goes to 0? It is d and d. How did you figure that out, though? Oh, because you said 1 over 0 is undefined? Okay. Do you remember if you look at the picture, I heard someone say that? It's actually a little bit helpful if you drew the picture, okay? What happens at 0? What's happening? Remember, limit is just a y value. So you're saying, what does a y value go to as you approach? What if I approached 0 from the right? What would the y value be approaching? Yeah, this would be positive infinity. What if I approached this function from the left, from 0 from the left? What would this be? Negative infinity. And remember what we talked about? If these two are not the same, then your answer is D and E, okay? But you could be a little bit more accurate about it if you wanted to. You could say the limit from the left and the limit from the right, okay? All right, it turns out whenever you have a problem like this, the answer is going to be positive infinity, negative infinity, or D and E. Actually, when you have an answer where, this isn't actually what I want to say. When you plug in into a limit problem and you get 1 over 0, the answer could be positive infinity, it could be negative infinity, or it could be D and E, depending on what your problem is. Okay, it turns out that these are your options. The answer is actually always D and E, okay, always D and E, but sometimes it's one of these, okay, and sometimes it's not. Sometimes it's only D and E. For example, this one is only D and E, okay, and we'll talk more about that later. What I want to tell you is now we're moving into a unit with limits. If you remember limits from September, those good times back then, okay, these will be better times, okay? We're moving into BC calculus. Things are going to become a little bit more abstract, okay? So if they become too abstract for you, I would suggest just knowing your homework really well, okay? Knowing your homework really well always helps, okay? But this would become a lot more abstract. And hopefully you've moved to a point in life where you realize in this class you just need to understand your homework, you need to do every single homework question, okay? All right, I want you guys to look at this problem here. Limit as x goes to 0 of e to the 3x minus 1 over x, okay? Do you remember in September when we talked about limits? When we did limits, what was the first thing you did? Always, if you tried to solve a limit problem, what was the first thing you did? You plugged in, okay? And that's going to be the same rule now. We're going to plug in first. And if we plug in here first, what we'll get is e to the 0, right? 3 times 0 is 0, minus 1 over. If you put 0 here, okay, you'll get e to the 0 minus 1 is equal to 0. What is e to the 0 equal to? 1. So what you'll get here is 1 minus 1 over 0, which is 0 over 0. Remember what we did? Oh, gotta do something else. Okay, and that's what we said for this problem. But the math term for that was actually indeterminate. When you get 0 over 0, what you have is an indeterminate answer, which means you got to do something else. The way you did it was not the way to do the problem. You got to find another way to do the problem. And in September, we talked about 4 ways to do this problem. You may or may not remember, but one was the factor. Okay, sometimes it's just by factor we figured out what the answer was. Another way was if we had a fraction over a fraction, we said, hey, it's a common denominator problem. Get a common denominator. Okay. We had another problem where we had if we had square roots, we said, hey, maybe it was a conjugate pair problem. Do you remember that? We said maybe factoring, maybe a common denominator, maybe conjugate pairs. And then we said maybe you just need to multiply out and simplify out. We said there are 4 methods to do it. Today we're going to learn another method, what to do when you get 0 over 0. Okay, and I'll talk about that in a second. What I want to do though is notice that if you put this into your calculator, okay, so I did put it into my calculator. We did it in first period, ran out of time, so it's better just for you just to trust me. Famous last words, just trust me. If you put this into your calculator, what happens is if you look at the limit, remember the limit is really just the y value of this as x approaches 0. In my calculator, if I did this, as x approaches 0 from the left, as x approaches 0 from the right, it approaches this y value, and I'm just going to let you know the answer is 3, okay? And I'm going to teach you a new method to figure out how to do this problem. Because if I look at this problem, I can say, well, I can try to factor, but nothing's going to happen. And there's no fraction over fraction, so common denominator is not going to work here. It already has a common denominator. Conjugate pairs, I don't know that that's going to work. I could try it. I mean, I could try multiplying by e to the 3x plus 1 over e to the 3x plus 1, but I'm just letting you know it's not going to work. And so what we're going to do is we're going to use a new method called L'Hopital's rule today to work some of these problems that aren't workable other ways. And I will do that in a few minutes for this problem, okay? Let's go ahead and pass up your warm-ups. I want to just talk about indeterminate expressions. Okay? Indeterminate expression is very abstract, okay? And it's very difficult to grasp, put our arms around, and that's why I think students have a lot of trouble with it. And it's actually even hard to believe, okay? So if I told you that 0 over 0 is indeterminate, you might believe me just because we've done a lot of problems like that, okay? And what that means is there's not an exact answer for it, okay? Another expression that's indeterminate is infinity over infinity. Actually, any permutation of this infinity over infinity is indeterminate. For example, if I said negative infinity over positive infinity, or negative infinity over negative infinity, or any permutation of this, all of these are what's indeterminate. And what do I mean? What do I mean by watching out for indeterminate? If you do a limit problem, and this is your answer, okay, then your answer is indeterminate. It means, oh, gotta do something else. And we're so used to the 0 over 0, but there are actually other expressions that are indeterminate. This is also indeterminate. Infinity minus infinity. That means you got to do something else, okay? You guys can see that there's not an exact answer to that, right? It's not necessarily infinity. You could have another answer. Another problem is 0 raised to 0. This is indeterminate. You think it might be, what do you guys think this answer might be? You think it might be 0, or you think it might be 1, depending on what you're looking at, right? It actually depends. It depends on what the problem is. Another expression is indeterminate that students argue with me about is 1 raised to infinity. What do you think that is? 1. But I can show you a problem where it's not 1. Like I can show you a limit problem where it's not 1. If I said the limit as x goes to, let's do n. The limit as n goes to infinity of 1 plus 1 over n raised to the n. Does that look familiar to anyone in here? That's the definition of e, okay? This is equal to e, okay? But look at this. If I plug in n goes to infinity, what would happen here? 1 plus 1 over infinity raised to infinity, right? If this stayed 1, while the bottom got larger and larger and larger, remember, this is abstract, you guys remember this. 1 over infinity is really what? 0, right? Okay, 0 plus 1 is what? 1. So isn't this 1 to the infinity? And you told me you thought that that was 1. Well, actually, it's not in this situation. Does that make sense? You can go put this in your calculator. Put this in your calculator, you graph it, and it'll go to e. It'll go to 2.7 something. It won't go to 1, which you think it should. Does that make sense? So there are lots of problems where you get 1 to infinity, and the answer is not 1, and you think it should be. But there are problems where it is 1, okay? So that's why this expression is called indeterminate, meaning just knowing that you have 1 to infinity doesn't give you an answer. Okay, so let's go back to September, and we'll talk about when we did this problem, how did we do a problem like this? So guys, I'm in your notes right now. So you guys pick up a paper with guided notes. Okay, I'm on the first problem with it, and follow along with me in your guided notes. Okay, this first problem here in September, I said, when you do a limit problem, the first thing you do is what? What's the first thing you do? Plug in. You always plug in. So I'm going to plug in. So it's 2 times negative 1 squared minus 2 over negative 1 plus 1. That gives me 2 minus 2 over 0, which gives me 0 over 0. Class? Oh, gotta do something else. What did you do in September? Factor? Okay. So guys, let's go ahead and factor here. If I factored, okay, that's the number one thing that helps a lot of times. Okay, I'll get 2 over x squared minus 1 over x plus 1. This is still a limit problem. Okay, this is a difference of 2 squares, right? So it's 2 times what? What's x squared minus 1? X plus 1, x minus 1 over x plus 1. All right. The good thing about factoring is if you have common factors, they factor out to 1. So what I got here is a new problem. The limit as x goes to negative 1 of 2 times x minus 1 over 1. If I plug in negative 1 here, tell me what your answer is. Be careful. Plug in negative 1 and tell me what your answer is. Negative 4. Okay, so this answer is negative 4. So a couple of things I need to tell you. On the AP test, the readers are very picky about this. You cannot put an equal sign here. things cannot equal 0 over 0 because this is an indeterminate form. So what you want to do here is actually put nothing, put an arrow, put equals, and then cross it out, because on the AP test, anything you put an X on will be not even looked at if you put an X on it, okay? So be careful about that. I'm not super careful about that because I don't agree with the rule, okay? But that's a rule that 3 years ago they started implementing, and they would take off, even if you get the right answer, they would take off a point on your free response, okay? So please make sure that you don't put that anything's equal to 0 over 0, even though it is. And the other thing is, when you go to college, you'll have picky professors who will not just take off 1 point, will count the whole problem wrong, okay, if you put something that they think is not true, okay? So I'm just warning you, the AP test is graded by half college professors and half high school teachers, okay? And they fight sometimes, okay? And I think that the college professors won in this situation, okay? And so you cannot put equals, they'll count it wrong. Okay, you know your answer is 4. What I'm going to do is teach you how to do this using a method called L'Hopital's, okay? And L'Hopital's rule says this, okay? If you plug in and you get 0 over 0, which we said we already did, okay, we can invoke L'Hopital's rule, okay? And the expression to do that, AP says you need to show that you know that they're using L'Hopital's, okay? So the way I'm teaching you that is just to put LH, okay? Show that you're using L'Hopital's rule, okay? And this L stands for limit, okay? So what I do is I copy this limit over here. The limit as x goes to -1, okay? And if you have 0 over 0 or infinity over infinity or any permutation of infinity over infinity, so, you know, these different permutations, if you have any of these, okay, you're allowed to invoke L'Hopital's, okay, just these, so just these 5 possibilities, okay? And what that says is you take the derivative of the top, and it has to be a fraction, okay, so you take the derivative of the top, which is 4x, and you take the derivative of the bottom, which is 1, is that right? Yes, okay, and then you solve this limit. Solve this limit. So if you put this -1 in, you get 4 times -1, which is -4. And once you plug in, you can drop the limit, okay? And that's L'Hopital's. And I'm sorry I didn't teach it to you guys, you know, at the beginning. But L'Hopital's isn't always the easiest method to use, okay? It is in this situation, but it isn't always. So let's look at another problem, okay? In September, how did you do this problem? We're doing a limit to infinity problem. Remember limit to infinity? It was either big over small was equal to d and e, small over big was equal to 0, or if you had the same, it was a ratio of the coefficients. Remember that? Okay, so this exponent, the leading exponent is 2. The leading exponent here is 2. So what's the answer here? 3/2. You guys good with that? 3 over 2. Okay, and you knew that very quickly because the leading terms were the same, had the same power, so therefore the answer is a ratio of the coefficients. Okay? All right, so let's look at this and let's use L'Hopital's here. If I plug in infinity, do you see that this would be infinity squared times 3 minus 1, right? Well, isn't that just infinity? Right? Infinity squared is just going to be infinity. Multiplied by 3, it's just infinity. Subtract it from 1, you still have infinity. So this would be infinity on the top. If I plug in infinity on the bottom, do you see the same thing? It'd be infinity. So what you have is infinity over infinity, okay, which means you're allowed to invoke L'Hopital's. Remember those 5 expressions, you can use L'Hopital's. Remember what this L stands for? What does the L stand for? Limit. So what I'm going to do is recopy this limit here, okay? I'm going to take the derivative of the top separately from the derivative of the bottom. Remember, this only works for fractions, okay? The other thing I need to tell you here is please do not use the quotient rule. Everybody good with that? We're not taking the derivative of this fraction. We're taking the derivative of the top, we're taking the derivative of the bottom for L'Hopital's. Everybody good with that? Every test, I get 2 students who do the quotient rule, okay? I want to kill them, okay, but it's illegal, okay? I'll go to jail, okay? So what I want to tell you is, please, I know you love the quotient rule, okay, but we're not doing the quotient rule here. We're just taking the derivative of the top. What's the derivative of 3x squared minus 1? What's the derivative of 2x squared plus 1? Okay, guys, what you can do here is, I know you can factor. You guys see you can factor and get the answer, but let's not factor. Let's pretend like this is the problem, because when you do L'Hopital's, all that means is the answer to this problem is the answer to this problem, okay? The answer to this is the answer to this. Well, let's say I forgot that big over small, small over big thing, okay? And all I do is I say, you know what, let's plug in infinity. Do you see that if I plug in infinity, I get infinity over infinity? That means you can do L'Hopital's again. L'Hopital's is like iterative. You could do it again if it applies. If you get something that's infinity over infinity, or 0 over 0. So let me invoke L'Hopital's. I write LH to let the reader know that I'm about to invoke the curse, okay? And so this L stands for what, guys? Limit. So this is going to be the limit as x goes to infinity of. What's the derivative of 6x? 6. What's the derivative of 4x? 4. What's 3 halves, right? This is really 3 halves. What's 3 halves as x goes to infinity? It's 3 halves, okay? There's no x to plug in. Did I get the same answer as in September? I did. But it was a lot more work. It was a lot more work, right? So while L'Hopital's works, sometimes there are easier methods. All right. In September, we did this method. Okay, we did conjugate pairs. I'm not going to do conjugate pairs with you right now just because it takes time. And I don't think you guys care, okay? So what I'm going to do here is L'Hopital's with you. But honestly, you could use both ways. And which way is easier in this problem? Both ways suck eggs. Okay, so it doesn't really matter. You pick whichever way you want. They both suck. Okay. All right, so I'm going to do L'Hopital's with you here. But guys, I cannot assume it's a L'Hopital's problem. That's the number one mistake students make, actually. They assume that the answer is 0 over 0. Okay. It's not necessary. Let me plug in first. What do you guys do first for every limit problem? Plug in. So let's plug in. If I plug in 7 here, what I'll get is a square root of 9, which is 3 minus 3 over 7 minus 7. And indeed, I do get 0 over 0. Indeed, I don't want to get a point off, so I'm going to cross out this equal sign. Okay, but you guys just be careful about that. I get 0 over 0, so what that means is I can invoke the curse. Okay, I'm going to put LH right there. What does this L stand for, guys? Limit. So I have the limit as x goes to 7. I'm going to create a new limit problem. And that new limit problem, the answer to that will be the answer to this old limit problem. All right. You need to know that I can rewrite this as, just this part here, as x plus 2 raised to the 1/2. You agree with that? So let me take the derivative of the top, okay? So that's going to be 1/2 times a quantity x plus 2 raised to the negative 1/2. Guys, it's chain rule, so don't forget, multiplied by the derivative of the inside. This happens to be 1, but it's not always going to be 1, okay? And then the derivative of 3 is just 0. Okay, is everybody good with the derivative of the top? What's the derivative of x minus 7? 1, that's pretty easy. Okay, so once you do the derivative, take a look at it and simplify it, okay? Because a lot of times you can move things around and the problem becomes a lot simpler. Especially if you have negative exponents, move them to the bottom, okay? So, or move them to the top. Just get rid of the negative exponents. So what I'm going to do is I'm going to move this thing around, and it actually turns out quite simple. Okay, did you guys get the same thing I got? Okay. Now, the answer to this limit problem is the answer to this limit problem, okay? This limit problem is not necessarily L'Hopital's problem. As a matter of fact, it isn't. Because if I plug in 7, I don't get 0 over 0. What do I get when I plug in 7? 1 over 2 times the square root of 9, right? Which is 1 over, and that is my answer. Okay, do you understand why I didn't do L'Hopital's again? Okay, you just act like it's a new limit problem. If you don't get 0 over 0, infinity over infinity, you just plug in and see what the answer is. Okay, so that's your answer. We would have gotten the same answer had you done conjugate pairs. You just have to trust me on that. All right, so we did this with our warm-up. Did you guys pass up your warm-ups already? Okay, we did this in our warm-up. We knew the answer was 3, okay? And what I want to do here with you guys is when I plug in, I'm going to get 0 over 0, and we talked about that. So I'm going to try L'Hopital's here. So let's try L'Hopital's, okay? I'm going to put an arrow to invoke the L'Hopital curse, okay? This L stands for limit, so this is a limit as x goes to 0, okay? I'm going to take the derivative of the top. The derivative of e to the 3x is what? 3e to the 3x. So this is 3e to the 3x minus 0 over, what's the derivative of x? 1. Okay, so what I get is a new expression. The answer to this limit is the answer to this limit. They're not necessarily the same problem, but their answers are the same, okay? I'm going to delete this negative 0. I don't really need minus 0. Okay, when I plug in 0 there, what do I get? 3. Okay, very nice. So this problem you could not have done with factoring, conjugate pairs, common denominator, multiply out and simplify. You had to actually use L'Hopital's, okay? Some problems you cannot use L'Hopital's. You actually have to use those little tricks that we talked about. So it just depends. You just have to have a lot of tricks in your bag and figure out what the best thing to use is, okay? This slide here, I'll post it online, but it's actually how to use L'Hopital's, some warnings about L'Hopital's. You got to have one of these expressions to invoke L'Hopital's curse, okay? If you don't have it, don't invoke L'Hopital's. It'll be wrong. That's the #1 thing students do wrong in the test and probably on your homework too, okay? You'll just assume every problem is L'Hopital's, and it's not. Plug in first. If you get an answer, that's your answer. Is everybody good with that rule? Okay. The second thing students need to understand is that you can invoke L'Hopital's again and again and again, right? Every time you get a new limit problem, if you get one of these answers as the answer, you could do L'Hopital's again, and we did a problem with that. And then the third thing students do wrong is instead of taking the derivative of the top and the derivative of the bottom, they do the quotient rule. Okay, so just be careful about that. It's not quotient rule that we're doing. We're taking the derivative separately. This slide right here, I don't know if you want to take a picture or just download it when you guys get it when I post it. You're going to want this for college, believe me, okay? I've had students email me and ask for it. Guys, after you guys graduate, I'm done with you guys, seriously, okay? You guys get new teachers, I get new students, okay? So the thing is, you guys, I've told you these things that you will need for college. I promise you, this is something you're going to want for college. I pulled this from different websites, and I couldn't find one book that had all of these expressions on it, okay? So when you learn indeterminate forms in college, these are indeterminate. These answers are all, oh, gotta do something else, okay? They're actually not final answers. This one looks like it should be a final answer, right? This one looks like it should be what? 1, but it's not. I can give you a problem where it's a limit problem and this is not 1. Let's see, this one looks like it should be what? 0, but it's not, okay? If you get 0 times infinity or infinity times 0, it's actually, oh, gotta do something else, okay? This one is really confusing, this 1 over 0. If you do 1 over 0, remember we did it in the warm-up? That's determinate. That answer is D and E, okay? Or it could be infinity or positive infinity, okay? But when you have 1 over 0 minus 1 over 0, that becomes possibly an infinity minus an infinity, which is indeterminate, okay? So it gets kind of complicated, but I think I got most, if not all, of the indeterminate forms in here. And if you know these forms, it'll help you a lot for college. It'll also help you for this test. For you, I think that you should know these. All of these you should know are indeterminate. This you should know are indeterminate. I don't think we come across this a lot, and we definitely come across this. Okay, all of these you need to know are indeterminate. Okay, the determinate forms you should know are determinate. They're a little bit easier to figure out. A little bit, not a lot. Infinity plus infinity is determinate, right? It is actually infinity. Okay, whereas infinity minus infinity is indeterminate. But negative infinity minus infinity is actually negative infinity. Actually, there is an answer. The answer is negative infinity. Okay, so you can take this home, go find a closet, sit in it for a while, and just take a look at all these expressions. And some of them will make sense, and some of them won't. Okay, you'll just have to memorize it. Let's look at this problem here. This is in your notes. Okay, and when we look at this problem, the first thing I would do is plug in, because I could try to find big over small, small or big, or whatever, but I'm kind of getting confused because it's e to the negative x, okay? So let me plug in and think what's going to happen here. If I plug into negative infinity, do you see on the top I'll get negative infinity times negative infinity, which is really just infinity squared. You guys good with that? So top I get infinity. On the bottom, negative infinity times negative is going to give me e to the infinity. But e is just a number, right? So a number raised to infinity is going to give me what? Infinity. Everyone good with that? So I actually get infinity over infinity here, which is actually a L'Hopital's problem. Okay, or I could use L'Hopital's if I don't see another method. All right, L'Hopital's, this L stands for what, guys? Limit. So please rewrite the word limit. Students who don't write the word limit do L'Hopital's, and then they don't know what to do with the expression that they've gotten. Okay, it is a limit problem. All right, let's take the derivative of the top. What's the derivative of x squared? 2x. What's the derivative of e to the negative x? Negative e to the negative x. So that's what I have. Oops, sorry, negative. Okay, let me plug in, I need to solve this problem now. Let me plug in negative infinity. What's 2 times negative infinity? Isn't it just negative infinity? It's negative 2 times infinity, but what's 2 times infinity? Infinity. Okay, what happens if I plug in a negative infinity here? Isn't that negative e to the positive infinity? And what's e to the positive infinity? Wasn't that just infinity? You guys good with that? A number raised to infinity, isn't that just infinity? All right, so do you see I can invoke L'Hopital's again? I got negative infinity over negative infinity. Okay, so when I invoke L'Hopital's, remember I write an arrow, I write LH, okay? And I know that this L stands for what, guys? Limit. Okay, so I rewrite the limit. I take the derivative of the top. What's the derivative of 2x? 2. What's the derivative of negative e to the negative x? It's e to the negative x, okay? Because you get a negative 1, but then that negative multiplies with this negative, you get a positive. All right, let me plug in infinity again. The top is just 2, right? If I plug in infinity here, or negative infinity, I get e to the infinity, right? E to the positive infinity. What is this answer? 2 over e to the positive infinity. 0. Do you guys see it 0? Because the bottom is going to get bigger and bigger and bigger and bigger. The 2 is going to hold still, so this answer is 0. Okay? So this is a problem you need to know. All right, let's look at another problem. Okay. First of all, let me think about plugging in infinity. Okay, remember, guys, you really can't plug in infinity. Okay, but conceptually, I'm plugging in infinity so I can see if I can use L'Hopital's or not. Okay, so I write it here, but you really cannot plug in infinity. So what I have here is e to the negative infinity times the square root of infinity. Agree with that? Okay, this is the tricky part here. What is e to the negative infinity really? It's 1 over e to the infinity, right? Okay, what is the square root of infinity really? It's really just infinity, okay? What is 1 over e to the infinity? As the bottom gets bigger and bigger and bigger and the top holds at 1, what's this going to be? 0 times infinity. And if you look at my indeterminate chart, this is indeterminate. You needed to know that this is indeterminate. That means, oh, gotta do something else, okay? And this is also indeterminate if you had infinity times 0. So I gotta do something else. And this is what you just need to memorize. For these limit problems, if you get 0 times infinity or infinity times 0, force it to a fraction. Force your original problem to a fraction and use L'Hopital's, okay? So let's go back to the original problem. How can I make this, force it into a fraction? The limit as x goes to infinity, right? If I force this to a fraction, look what happens. When I plug in infinity, what do you get? Infinity over infinity. Wow. If I get infinity over infinity, what am I allowed to do? Invoke L'Hopital's, okay? So here, when I forced it into a fraction, because guys, L'Hopital's only works with fractions, okay? When I force it into a fraction, I get infinity over infinity, which gives me the ability to do L'Hopital's. Remember what the L stands for, guys? Limit. So please rewrite the limit. What's the derivative of the square root of x? 1 over 2x to the negative 1/2. Is that right, guys? Okay. What's the derivative of e to the x? E to the x. Guys, once you take the limit, step back and get rid of all of your negative fractions. It really helps. So this is really the exact same thing as 1 over 2 square root of x e to the x. What's the answer? What is it, guys? Say it loudly. It's 0. Why? Because this is going to infinity down here. This is going to infinity down here. The 1 is holding at 1, right? The bottom's getting bigger and bigger and bigger. Your answer is 0. You have a question on your test almost exactly like this. Possibly exactly like this. Okay? All right, let's look at this problem here. Sorry. You're going to plug in 1. If you plug in 1 here, okay, you get 1 over 0 minus 1 over 0. Do you remember when we talked about 1 over 0 is d/e, or it's possibly infinity? Okay, we don't know what 1 over 0 is in this problem. So it's possibly infinity, and infinity minus infinity is actually indeterminate. So back to the drawing board. Guys, whenever you have 1 over 0 minus 1 over 0, make it into one fraction. Because L'Hopital's you can use if you can force it into one fraction. So what we're going to do is still keep it as a limit problem, but force it into one fraction. Remember when we did common denominator in partial fractions? Okay, force it to have the common denominator of them multiplying together. So if this has ln of x, then the top just needs to have x minus 1 times x minus 1. If this already has x minus 1, then you just need to multiply by ln of x over ln of x, and that's what you get right there. Okay, you guys good with that? All I did was get a common denominator, okay, and did fractions. Okay, and then what I'm going to do is I'm going to plug in 1 here. So when you plug in 1 here, do you see you get 1 minus ln of 1 over ln of 1 times 1 minus 1. Guys, when you plug in, you can drop the limit. Okay, what do I get? 0 over, did you get 0 over 0? 0 over 0. So what does that mean when I get 0 over 0? I can invoke L'Hopital's. Okay, what does that L stand for? The limit. Okay, so just copy that limit expression. That means I can take the derivative of the top. What's the derivative of x? 1. What's the derivative of 1? 0. And what's the derivative of ln of x? 1 over x, right? U prime over u. Okay, so this was my u, so it's 1 over x. All right, what's the derivative of ln of x times x minus 1? One wrong answer is 1 over x times 1. Okay, because it's not the derivative of this times the derivative of this. How do you do the derivative of two factors multiplied by each other? Product rule. So it's the derivative of the first times the second plus the derivative of x minus 1, which is just 1, right, times the first. Okay, I'm in a good place right now. I've got a new limit problem to solve. I'm going to plug in 1. When I plug in 1, I can drop the limit. I get 1 minus 1 over 0 plus ln of 1. And what does that give me? 0 over 0. Except I'm not going to put 0 over 0. You didn't see me do that. Okay? And what happens when you get 0 over 0? You can invoke L'Hopital's again. How fun is this? Okay? So, guys, I'm going to see that this L stands for what, guys? The limit. Rewrite limit. Okay, I'm going to take the derivative of the top and the derivative of the bottom. But guys, before I do that, I know what's about to happen. So let me just tell you, what you're going to do is distribute this first. It makes things a lot easier. Okay, so distribute this on the bottom. So what I'm going to get on the bottom here is actually 1 minus 1 over x plus ln of x. Are you guys good for that denominator? I mean, I'm doing this because I know what's going to happen. It's going to help. Okay. The other thing you need to know is actually put a star by this problem. It's on the test. So when you're on the test, you probably want to do this too because it's going to help you. Okay, so what's the derivative of 1? 0. Okay, let me rewrite. This is really 1 minus x to the negative 1, right? So what's the derivative of negative x to the negative 1? That's negative 1 times negative, which is positive, x to the negative 2. Let's good with that. On the bottom, the derivative of 1 is going to be 0. The derivative of negative x to the negative 1, we already did that on the top, right? That's going to be x to the negative 2 plus 1 over x. Hopefully you guys see why the negative went out, because there's a negative exponent times a negative, so I got a positive. Okay? All right, so this is what I have. This is the answer. The answer to this is the answer to this up here. Okay? But what is the answer to this? At this stage, I would actually plug in my 1. Let me see here. rewrite this problem. Get rid of your negative exponents. So that would be 1 over x squared over 1 over x squared plus 1 over x. Okay, get rid of your negative exponents, because who knows how to plug into a negative exponent? I don't. Okay, get rid of those. Now plug in your 1. Something beautiful happens. I mean, it's so beautiful, it makes you want to sing. What happens when you plug in 1? Did you get 1/2? That is your answer. Okay, so such an ugly problem, but look how beautiful the answer is. Look at that. Babies turn out like that too. Okay, all right, let's look at your last problem, okay? Before we do your last problem, you need to know this limit property right here, and I'll put these on the slides. But you need to know that the limit of a log is equal to the log of a limit. And the log of a limit is equal to the limit of the log. You just need to know that. Okay, it's a limit property we talked about long ago, but we never used it, but it's going to become useful in this problem here. Okay, so this problem is actually very difficult. Why is it difficult? It's because you have the limit of f of x, something with an x in it, raised to something with an x in it. Okay, so you have a base with an x, and you have a power with an x. Okay, if you ever have the limit of something with a base of an x and a power of an x, then you want to do this. This is what we're going to do today. You're going to just set that equal to y. Okay, and I'm going to make a deal with you. I need you to keep your end of the deal. Okay, and the deal goes like this. If I find the answer to y, I find the answer to the problem. Deal? You guys agree? Okay, so what I'm going to do is I'm going to manipulate this a little bit. I'm going to take the log of both sides. Now, why am I taking the log? Because I have this x in the exponent. And I know this little trick with logs, right? You can take exponents out if you have a log, okay? But the thing is, the log of a limit is the same as a limit of a log. So I'm going to switch these. So the limit as x goes to infinity of the log of 1 plus a quantity 2x raised to the x power is equal to the log of y. Okay, so all I did was take the log of both sides. Okay, then I said the limit of a log is equal to the log of a limit. All right? Why did I do that? Because now when the log is the log of this expression, what can I do with this x? Okay, move it to in front of x, but guys, you cannot move it to the in front of the limit. Okay, it doesn't take it out of the limit, but it definitely takes it out of the log. Okay, so my new problem is a limit as x goes to infinity of x times the limit of 1 plus 2 over x is equal to ln of y. If I plug in infinity, if I just focus on the left side here, just the left side, if I plug in infinity, what I'll get is infinity times ln of 1 plus 2 over infinity. Right? What's 2 over infinity? 0. What's 1 plus 0? 1. What's ln of 1? 0. So this goes to 0. So what did I get here? What do I do when I get infinity times 0 or 0 times infinity? Force it to a fraction. Force it to a fraction and do L'Hopital's. This is actually an indeterminate form. Okay? I'm going to force this into a fraction and do L'Hopital's. Now, unfortunately, this is not easy to force into a fraction, or is it? Can you guys do that? Remember, algebra matters, so I can't just do whatever I want, okay? But if I divide by 1 over x, wouldn't the x flip up and I'd get the same answer, right? I'd get the same expression. So it's a little bit tricky, but I can force this into a fraction, okay? And this will be equal to ln of 1. All right, so what I'm going to do is I'm going to plug in infinity now. If I plug in infinity now, let's see what I get. This will be infinity here. And this is really 1 over x, right? So this would be 1 over infinity. You guys agree with that? 1 over x, 1 over infinity. So the top here, this is going to, what's 2 over infinity? 0, right? Because the bottom gets bigger and bigger and bigger and bigger. The top holds still. What's ln of 1? 0. Okay, what's 1 over infinity? Okay, if I get 0 over 0, what can I do? You can invoke the curse. Okay, so let's invoke it. We're going to invoke L'Hopital's rule. Okay, and so, guys, this L stands for limit. Please do not forget to put limit. Okay, the L stands for a limit. All right, we're going to take the derivative of the top and the derivative of the bottom, because that's what you can do when you get 0 over 0. Okay, so you actually should put 0 over 0 somewhere. That's another rule they said. Okay, you have to put 0 over 0 somewhere. I was kind of like, well, if they did L'Hopital's, then they know it's 0 over 0. But anyway, you can't argue with them. All right, so guys, ln of, this is your u, right? You want to take the derivative of ln. So do you agree that's u prime over u? You guys good with that? So let me just write that for now. U prime over u. And the derivative of this is negative x to the negative 2. Everybody good so far? All right, let me get this u prime over u. So this is the limit as x goes to infinity. Okay, this is really the u is equal to 1 plus 2 times x to negative 1. I'm rewriting it, right? So what's u prime? If this is u, what's u prime? Negative 2x to the minus 2, right, over u. Okay, guys, make sure we keep this consistent. My u is 1 plus 2x to the negative 1, all over negative x minus 2. That's good so far. Okay, now I've got a lot of negative exponents here. I'm really bad with working at negative exponents. So give me a suggestion. I could change it to positive. Do you want to do that? Or how about, I've got 2 fractions here. How about if I just change it to 1 fraction first, see what happens, okay? Dividing fractions easy as pie. Flip the second fraction here and multiply, right? So let me just make it 1 fraction. So 2x to negative 2 over 1 plus 2x to negative 1 times, I'm going to flip this fraction and multiply. So we get 1 over negative x to the minus 2. Okay. Actually, something very beautiful happened here. Do you see it? Yeah, the x minus 2's actually cancel out. The negative negatives actually cancel out too. Okay, so I could rewrite this problem. I haven't plugged in infinity yet, so let me just rewrite this problem as 1 plus 2 over x. Okay. And as x gets larger and larger and larger, what does this answer become? This becomes 0, right? So I get 2 over 1, which is just 2. Okay, but be careful. My answer is not 2. I just worked the left side of this problem. I just worked this side of this problem. This side of the problem is 2. So what's 2 equal to? ln of y. So I know 2 is equal to ln of y. And we made a deal. Okay, we made a deal. If you could solve for y, you could solve for the answer to this problem, right? So how can you isolate your y here? E both sides. So what's your y equal to? E squared, and that is your answer to this problem. Was that beautiful math or what? Okay. A little tidbit I wanted to tell you. When do you want to use this problem? It's whenever, you can look at your homework, whenever you have the limit of some x to an x, some x to an x. So you can look at your homework, you can see when you have to use this sort of thing. Your homework is the front and the back. It starts out easy, I'm just letting you know, and it gets a little tougher and tougher.